This is chapter 25, example 1. What we have here is the need to design a circuit, or essentially a state machine, that will blink an LED at one of two duty cycles and one of two frequencies. It's either going to blink at half the system frequency with a 50% duty cycle, or a quarter of the system clock frequency at a 25% duty cycle. So it turns out this problem is very nicely set up. Let's go ahead and do this. First step is always to draw a circuit. There's my LED, has a clock, and this particular circuit has a button. We know we need a state machine for this one, and the best idea is to just draw something. If in doubt, we're just going to plop down some states. So we know we need to do a state diagram that generates a 50% duty cycle. We know how to do that. We've done it before. So let's just draw that. This solves the 50% duty cycle part because I've got it on and off. That is a good start. What we're missing here is the transitions on this one. Before, we had these transitions unconditional for the 50% duty cycle. Now we have to make it a little bit differently because we have an input condition here, so the button. Essentially what we're going to do here, we're going to say if that button is on, we are going to go into this 50% duty cycle. Okay, and if the button remains on, that's where it gives us the 50% duty cycle. So that's a good start. Now we have to worry about the other part of it. We're going to say if someone magically turns the button off right here, that's okay. Okay, and we'll do that one more time. Once again, the button's off. And the button's still off. And we've got a S off. It's off. Okay, and lastly, we can just send it back here because we know that's going to happen. What we have here is a state diagram that does most of what we need. So what's missing in the state diagram is some of the transitions are missing, and some of the transitions are not complete in that they don't have conditions. Go step through this one by one here. So if this button works for the 50% duty cycle, well, it turns out that it works for the 25% duty cycle also. So this condition is either button or button not, which button or button not equals 1. 1 means it's always going to transition, unconditional transition. This state we're done with, it has two transitions leaving it, both the button on and button off transition. This first state's done. Second state looks like it's done because I have two transitions exiting the state, the button not and the button. So we're going to call that done. What we need to worry about is this third state. What happens? We've got a button not, but what happens when the button turns on? And so when the button turns on, we are going to essentially start this thing over. Okay, and then at that point, it's going to be a little bit messed up because at that point I have some weird cycle. But the problem said that's not a big deal when I actuate the button. Lastly here. Okay, so once again, this third state here, I have a button and a button not. That's good. Last state here is what do I do in this state? So if the button is off, that means I have the 25% duty cycle. But what happens when the button turns on? It turns out that very much like these states, when someone turns the button on, it goes back to the beginning to start the 50% duty cycle. So once again, this equals 1, or you can put a unconditional transition there. And so we are done with this problem. When you're doing these problems, always start out with the top level black box diagram. If in doubt, don't get stuck. Start plopping down states and filling them in. You don't have to make it complete the first time through. What you have to do is by the time you're done with it, it needs to be complete, which is what we did.